Hey everyone, so today we're going to start with transformations. Okay, so what we did at the beginning of this, so these first couple of pages are just parent functions. They're your functions that you can start out with, so your different characteristics like linear, quadratic, cubic, so on and so forth. So one thing about transformations is there's a difference between actually graphing it exactly to sketching it. Okay, but with all transformations, to know you're doing it correctly is the good thing is to write down what should happen. And then of course, if it's just a sketch, if you know the shape of the parent function, then you can sketch it out. But if you need to know it exactly, then we use a table and we can do those coordinates exactly. And you can just make sure that the movements are made from the parent to whatever function you're dealing with. The other thing about this chapter that you want to get used to is function notation, because not all functions have a parent to it, or their parent is what you start with and then you move it around. So you need to be careful with notation and everything like that. We're going to talk about inside and outside a lot. So just remember when you're doing function notation, you're talking about what's going on the inside. So there's going to be a lot of examples just so we can see all these different types of ways that we can deal with transformations. So let's talk about the parent functions first of all. So the first page here, we have linear and quadratic. So you should seem familiar. Now, most of our normal parent functions here, when we talk about a table to be able to do the exact transformation, I want you to start with your normal, and you can switch this from vertical to horizontal during the notes today. We do a lot of horizontal, but I like doing vertical too. Is you want to get both negatives and positives involved for the parent function. Okay, so more than likely, most of our functions will start with -3, -2, -1, 0, 1, 2, and 3. Okay. Now, of course, if you're dealing with your parent function, all you're doing is you're plugging in the x and solving for y. So with linear, meaning just x, we would have just -3, -2, -1, 0, 1, 2, and 3, right? Because we're just plugging it in. And that's our parent function for our table that we're going to start out with. For quadratic, again, nothing too odd here. So we're going to start with -3, -1, 0, 1, 2, and 3. And then, of course, when we plug it into an x squared there, we have 9, 4, 1, 0, 1, 4, and 9. And of course, like I said, if I'm going too fast, what I did was all I did is I said -3 and I plugged it in the function. -3 squared is +9. Now, for those of you using your calculator, it might come out to be -9, but that's because you're just squaring the 3 and then multiplying it by negative. So you want to make sure that you put parentheses, -3, and parentheses, and squared. Okay. So, and these are domain and range and everything, what our graph should look like. I'm going to focus on the table and the shape of it right now. So this is quadratic. This is an x squared. Now, some of these I'm not going to do the table for, okay, because there are normal -3 to 3. Okay, here's our absolute value. Okay, so that's our V. Again, this one's going to be -3 to 3. This is our cubic. So we have this kind of nice little squiggly shape. And don't forget, this is normal too. This is -3 to 3. Here's where we got to watch out. It's our square root function. What do you see as an issue here, let's say with the graph, if you were to describe this in some way? Hopefully you're saying, well, we can't take the square root of a negative number. Very good. So when we do our table for transformations, we're not going to do negative numbers, right? We're going to start with 0. Now, we want to put in numbers for the table that we can do without a calculator. Okay, so to get the square root of some number, we need to use perfect squares, right? So 0, 1, 4, 9, 16. We could go further if we need to, but probably won't be on the graph, so there's no need to. So when I take the square root of each of these, I get 0, 1, 2, 3, and 4. Okay, again, this is a square root function. Cubics. Okay, just our cube root function, just like the square root function, we have to use special numbers just so they come out to integers and not decimals. Okay, so and the difference here is we can use negative numbers, right? So I am going to think of cubes, okay, and I want negatives and positives. So I'm going to go negative 27, negative 8, negative, let's see, that's 2, negative 1, 0, 1, 8, and 27. So when I plug these numbers into the equation here, the cube root of negative 27 is negative 3. And we have negative 2, negative 1, 0, 1, 2, and 3. All right, the last two down here, exponential, this you did in secondary one. What I want to do with the exponential is we're just going to talk about sketching it. We're not going to do exactly, but I will tell you there is one point, no matter what, we can do exact. It's that one right there. That's our y-intercept, right? So if I want to make sure that is exact, right? That would be at when x is 0, y is 1. The other thing I want to remind you of is that for exponential functions, we have a horizontal asymptote, in this case, at y equals 0. Okay, let me get a pen here. So it will never cross the x-axis for the parent, that is, right? Because when we start to transform it, that changes. Okay, and this year we started to deal with rational. Again, we're doing sketching it so much, not exact. So when it comes to sketching these, two things you want to keep in mind is that there's a vertical asymptote at x equals 0. Right, that y-axis, and we have a horizontal asymptote at y equals 0. Okay, so when I talk about these asymptotes, the reason why I'm doing it is because when we sketch these, we're going to move these asymptotes. In the future, will you be able to do everything exact? Yes, but we're just getting used to these functions right now, okay? So these were our parent functions. Now, what do we do with them? All right, well, let's talk about movements, okay? So what I want you to keep in mind is I'm going to write this in function notation, and I'm going to use our letters, right? So we get a function b times x minus c plus d. Okay, now what does that mean? Well, f parentheses, that's the function. Right now we're just doing a general form. So this could be cubic, this could be exponential, it could be whatever. But this is where I talk about inside, and the a and d are on the outside. Okay, so when I talk about inside a function compared to outside a function, we're going to talk about what a, b, c, and d do to the function itself. What transformation does it make? So stretch or shrink. Well, this comes from a or b. Okay, so if a is greater than, let's see, let's do it this way. A talks about a vertical stretch or shrink. There we go. Stretch, shrink. Now, what does that do? Well, if the absolute value of A is greater than 0, it stretches it, pulls it. So if I were a quadratic, right, x squared, and I multiplied it by 2, it's gonna go stretch those arms, okay? Whereas if the absolute value is less than 0, okay, which means less than 1, between 0 and 1 technically, it would be a shrink, or this way. So it pulls it down. Okay, it makes it wider. So in other words, let's do narrow, wide. Right? Now, what does B do? Well, B does a horizontal. It's on the inside. Everything on the inside has to deal with the X. So an X is a horizontal, right? On the outside, it deals with Y, which is a vertical. Okay, so that's stretch or shrink, but it's the opposite to what we think. Okay. Now, this year, we're not going to deal so much with the horizontal. So it's the opposite. So when it's a fraction, it actually horizontally stretches it. When it's greater than 0, it horizontally shrinks it. Now, if you do have a B, it's going to be done to the X values of our table. Again, like I said, more than likely, we're not going to deal with it this year, but you will in the future. Reflection. Well, again, that happens with A and B. So if A is negative, there is a reflection over the X axis. Okay, so if your graph's up here and it's negative A, it now flips. Okay, same thing. B, when B is negative, reflection over y-axis. When I ask you guys to write down the transformation, remember to tell me if it's a vertical stretch or shrink, horizontal stretch or shrink, and which axis is gonna flip over, okay? Now shift, this happens with C and D. So C though, we do a movement of right or left. Now, what we need to remember is that since it's on the inside, remember up here, we said we did the opposite to what we see. Well, same thing for the shift. Okay, so right, when we think of going to the right, we think a positive, but because it's on the inside, it's actually going to be a negative C, hence why the opposite. Okay, so minus C, where the left is going to go to the right C, not right, positive C. So if I say a +3, it's going to be moving to the left 3. So it's opposite. Okay, and D has it move up and down. And this is exactly what we see because it's on the outside. So up has a +D and down has a -D. Okay, now these are our movements. So let's see what we can do from there. All right. So first of all, I put all the parent function tables in there already. So take time to do that. I also want to make sure you're describing the transformations so that way we can check our graph after. Okay. So, and I also want you to look at also look at the parent function. So first of all, the parent function is like this. This is cubic, right? So the parent function starts like this. This is in function notation. So it's saying we're going to take that parent function and add 3 to it. So in other words, it looks x cubed plus 3. Okay. Well, plus 3 is on the outside of the function because the inside would be in that cubic right there, right? Okay, so on the outside we have a plus 3. So what letter is that? That's D. So what does a plus D mean or plus 3 mean? Well, it means it's going to go up 3. So at the end, I should be able to look at my graph and say, yeah, it didn't move. Remember, cubic starts here and it goes like this. Okay. Now, it's on the outside, like I said before. So outside, you do it to y. Outside, you do it to y. So we're going to add 3 to all of these. So this would be negative 24, negative 5. Well, let me put that plus 3, right? We're going to add 3. So that would be 2, 3, 4, 11, 30. Okay, now, of course, I'm not going to be able to graph all of these things because we only have a 10 by 10 and this goes up. So let's make sure that I'm only graphing what I have. So negative 2, negative 5, 1, 2, 3, 4, 5. Negative 1, 2, 0, 3, 1, 4, 8, 11. So it's going to be somewhere up here, right? So now also be careful because it's so tempting, right, to do that linear, but we have to remember it's in that cubic shape. So we got to keep that cubic and look, it looks like it went up 3. Okay, absolute value. What does absolute value look like? Well, that's our V. Make sure that you write draw your V, not your quadratic. If I were to look at this minus 5 is on the inside. If I were to write this in actual absolute value form, on the inside, we're subtracting 5. So that's what it would look like. Now it's on the inside. So what letter is that? That's C. We have a minus 5. So minus tells us to go which way? It tells us to go right. Okay, so that's what should happen. Now, because it's on the inside, we do it to X. Okay, inside you do it to X. And we're going to do the opposite to what we see. So this is subtracting 5. So what we're actually going to do is add 5 to it. So inside you do it to X, but you do the opposite to what you see. I see a minus 5, so I'm actually going to do the opposite. So I'm going to add 5. So negative 2, no, sorry, that would be positive 2, right? So positive 2, positive 3, positive 4, 5, 6, 7, 8. Now, if you were wondering, wait, what did she know to graph down here? I graphed the outer to outer. Okay, do you guys see that? So same thing here. What I'm going to do is graph the outer coordinates. Okay, so 2, 1, 2, 3, 1, 2, 3. 3, 2, 4, 1, 5, 0, 6, 1, 7, 2, 3, or 8, 3. What do you know? Did I move it to the right? Yes, I did. Now make sure, because we know that this is going to be a V, that we don't make it quadratic. And look, started here, move to the 5, move 5 to the right. Okay. X squared. Well, that's our parabola. Okay, there's all of our parent function. Now, what would this look like? This would look like 3x squared. It's on the outside, so we're going to do it to y. So what is this? This is a vertical stretch, right? Because it's greater than 0. Well, the absolute value. And it's going to vertical stretch by 3. Okay, now outside does it to x or y? Y. We're going to do exactly what we see. So we're going to multiply all the y's by 3. So 27, 12, 3, 0, 3, 12, 27. Okay, that's all I have there. So I'm going to graph that outside stuff. Now, I'm going to graph these 3 first because I can see that. Then I might sketch this that goes off the graph. So 0, 0, -1, 3, 1, 3. So see how that stretched it up? Okay, and this would be 12. So it's going to be right around here. Now, this one, of course, is quadratic. So we're going to try to make it look like that U. These arrows keep going. Woo. Okay, so we're dealing with the same function here. Okay, so it's 1/3 x squared. Okay, what does that do? Well, there's a vertical shrink. And this is by 1/3, or think of it, because I already used the word shrink, that I'm doing a shrink by 3. Okay, it's on the outside. So again, I'm going to do it to y. So 3 4/3, 1/3, 0, 1/3, 4/3, and 3. I'm just going to do, because it's the outside numbers, right? Okay. I want to make this more exact than I can. So I'm going to graph this one, this one, this one. So -3, 3, 1, 2, 3, 0, 0, and 3, 3. Now, as you can see, we're going wider. And make it look like a parabola, not an absolute. There we go. All right, be careful when you do your parent function. Remember, we're doing square root, so we need perfect squares in the x. Now, here, this would be negative on the outside. Okay, so that's how that would look. What letter is that? If you go back to the parent function stuff, that's A. So if you remember, if you go back to the beginning, that's a reflection over what axis? The y axis. Okay. So that's on the outside. Outside does it to what? X or Y? Y. We're going to multiply by -1. 0, -1, -2, -3, -4. Okay, I'm going to graph the outside coordinates, so on and so forth. So 0, 0, 1, -1, 2, 3, 4, 4, -2. Now, as I'm graphing these right now, what was the shape of the square root? If you remember, it looks like this, right? Go back to your parent function if needed. So if we reflect it over the y, we're going to flip down. And what do you know? There it is. Perfect. All right, we're doing it again, but as you can see, that negative is on the inside. Now, many of you might be like, but heck, man, wait, we can't take the square root of a negative. That's correct, but we can make our x's negative, right? The square root of -1, so on and so forth. So if we remember, the negative on the inside is a reflection over the x-axis. So this is why it's important to tell me what axis it goes over. So if you look at the parent function, right? This is the parent function. We're going to flip it this way. Okay. This way. Okay. On the inside, do we do it to x or y? Do we do it to x? Now, usually I talk about doing the opposite, but the truth is with a negative right there, when we talk about multiplication, we talk about the reciprocal. Well, what's the reciprocal of -1? -1. Okay, I'm going to make sure I remind myself that we're multiplying, not subtracting. So we get 0, -1, -4, -9, and -16. Of course, we're not going to be able to graph all of these because it only goes from -10 to 10, right? So let's graph these. 0, 0, -1, 1, -4, 1, 1, 2, 3, 4, and that's at 2, -9, 1, 2, 3. There we go. And what do you know? Did it reflect over the y-axis? Yes, it did. Perfect. All right, let's try to get it a little bit more complicated here. So cubic, right? So it's going to look like this. I'm going to write it in our equation notation because this is function notation. So the 4 is on the outside and that x plus 1 is on the inside. The inside is what is cubed. Okay. So what is happening here? Well, let's see. We do a vertical stretch by 4, and it's on the inside. That's our C value, right? Now, adding 1 would be going to the left 1. Now, because we have 2, we have to talk about order and remember inside or outside. So on the outside, I like doing the outside first. The outside stuff we do to y. There's only one thing on the outside. It's multiplying by 4. And then on the inside here, we do to x and we do the opposite to what we see. So we're going to subtract 1. So -4, -3, -2, -1, 0, 1, and 2. Now multiplying by 4, sometimes let me get the calculator. I also have to charge my calculator. Yep. Okay, 27 times 4, 108. -32, -4, 0, 4, 32, 108. Now, remember, what is that supposed to do? Well, it's supposed to stretch and go really fast up and then move it over to the left. So let's see if we do that. Now, when I graph this, I'm going to graph, of course, the outside coordinates. And it looks like the only 3 you can graph are right there. So -2, -4, 1, 2, 3, 4. -1, 0. And 0, 1, 2, 3, 4. Now, again, the other ones I can't get on this graph, but remember, this is not linear, it curves, guys. So I might go from here and curve it down in here and curve it up. Okay, shape is going to be part of your answer. Now, did I go to the left one? Well, it would have started here, so I did go left, and it made it really inside where I'm like pulling those ends. So yes, we're good. Whew, so much to do. All right, let's see what else we've got here. This is x cubed again, so we're still doing this. That would be negative. Now the x minus 3 is on the inside of that cubed plus 2. So as you can see, we're doing 3 transformations here. So let's talk about each transformation. Well, this negative out front here is a reflection over y-axis. On the inside here, we're going to think of the opposite, right? Which way is it moving? This is our left or right. So this is a minus 3, so we're going to go opposite. So right 3, and this plus 2 on the end, that's the D, that's up and down. So we're going up 2. So remember, opposite to what's on the inside. Okay, and remember our shape looks like this. Whew. Okay, now we have 2 things that are going on the outside. Remember, outside is the y value. So we have that negative and that plus 2. When you're doing multiple stuff to the inside or the outside, you always work from left to right, just like we read. So I'm going to multiply this by -1, and then I'm going to add 2 to it. Now it's on the outside, so I do exactly what I see. But for my x values here on the inside, I do opposite to what I see. So I see a -3, so we're actually going to add 3 to it. All right, now that I've known what I'm doing for movements, let's do it to our table. So we get 0, 1, 2, 3, 4, 5, 6. This changes to 27, 8, 1, 0, -1, -8, -27. Then we're going to add 2 to each of these. So 29, 10, 3, 0. This would be 1, -6, -25. Okay, so it looks like we're going to be able to graph these 4 here or 5 here. Now remember, it's the outside. Okay, so 1, 10. 2, 3, 2, 3, 3, 0, 4, 1, 5, and then 1, 2, 3, 4, 6. Okay, and then that's it there. So right 3, up 2. I just want to make sure that I'm having these correct here, guys. 0, 0. Okay, times negative plus 2 plus 2 plus 2. That looks right. But I'm just wondering because, let me just double check something. Something doesn't look correct. And I want to make sure. Plus 2. All right. Sorry, guys. 10, 3, 2. This should be 2 because I forgot to add 2 to it. Did you guys see that? I'm glad I caught that. See, now, how did I know this? Because mistakes are great to go through, right? Well, as you can see, I'm gonna I'm going to flip this up and then move it. But if I look, this shape isn't quite, you would think that these two, if this were the middle, that these two would be the same distance away. So I knew something was up there. And I am right, because that is 3 there, should be at 2. Right? 3, 2, 1. And then, of course, I put this at -1, but it's at 1. And that's why, there we go. And now do you see where the distance looks the same? Awesome. So when I put this together, I can double check, right? So did I flip it? Yes, I did. Now, this would have been the middle, right? 0, 0. I went over 3 and up 2. And that's what my transformation said. All right, now a different form that we can do this. We're almost done, I promise. Okay, so write the equation of the function. Following transformations are applied in order. So this is one thing that you need to keep in mind. We're talking about in order, okay? So the first thing I'm gonna do is a vertical shrink by a factor of 1/2 or 2, multiplying by 2, right? So multiplying by 1/2 by actually the shrink of 2. Okay, so the vertical is on the outside. So right away, this is what I would have. 1/2 x squared. That is on the outside. Okay, now reflecting over the x-axis, that's a negative on the outside. Right? So if I took that, then I would have a negative 1/2 x squared, and then shift up 4. Up means we're going to add 4 to the outside because it's up. So our final answer is negative 1/2 x squared plus 4. Now, this is in the equation notation. If I were to do it in the function notation, I would just have negative 1/2 f of x, because nothing is happening on the inside, plus 4. So I want to show you both notations just in case you have to deal with it on your practice. Okay, vertical stretch by factor of 3, that would be 3. Now look at our function. 1 over x. Okay, 3 on the outside. So that's 3 times 1 over x. What else can that look like? How do you multiply fractions? Well, we multiply straight across. So 3 over x. Okay, so here's where we start. That's what the first one. Now we're going to go down 2. Down 2 means that we're subtracting 2 to the outside. Okay, and then right 4, well, right 4 is on the inside. So that means we're going to do the opposite. So we're going to subtract 4. Okay, now when it comes to the rational function, where's inside, where's outside? Well, I'm going to give you a little note here. Inside happens exactly to x, and outside, just like where that 3 is, happens on the outside here. Okay, so that's exactly what I'm going to do. So I'm going to start here because we already did a vertical stretch. We go 3 over. Now on the inside there, I'm going to subtract 4. So x minus 4. And on the outside, I'm going to subtract 2. That is our function. Well, that's our equation. Now, if I were to do it in function notation, it would be easier, right? Because I would just say 3 f of, on the inside, we're subtracting 4. Now on the outside, we're subtracting 2. Function notation when it comes to rationals are a little bit easier, but we have to remember what happens exactly to x is the inside and then the outside. Whew. Okay, now this is going to be our parent function. It's not our normal equation, but it still works. Now, how do I do that? Well, what I did is on my table is I took all of these coordinates that I know it goes through. Okay, all of these coordinates right here. And I put it in my table. So at -2, it's at 1. At -1, it's at -1, 0, 2, 1, 1, so on and so forth. We can still do transformations just like this, okay? So let's talk about what happens here. We're going to reflect across the, or over the x-axis. We're going to do a vertical stretch by 2. Right here, remember this is inside, so we do the opposite to what we think. So we're going to go right 3 and up 4. Okay. Whew, this is a lot. So let's do outside stuff first. So outside we have this -2 and we have this 4. Now, by the way, when we're multiplying, before we could have done negative, multiply by -1 and then multiply by 2. But that's the same thing as multiplying by -2, because I'm going left to right, -2, and then we're adding 4, because that's on the outside, and outside you do it to y. On the inside, we do it to x, and we do the opposite to what we see. So we see a -3, so we're going to add 3 to x. Okay, so I get 1, 2, 3, 4, 5, and 6. Okay, multiply everything by -2. -4, -2, -6, 0. I forget we're dealing with this, so it's not always consistent. Okay, then we're going to add 4. So that's 2, 6, 0, 2, -2, and 4. Then I'm going to graph all this outside stuff. Okay, so 1, 2, 2, 6, 1, 2, 3, 4, 5, 6. 3, 0, 4, 2, 5, -2, 6, 1, 2, 3, 4. Okay, so it goes do, 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 do. Okay, and look, does that flip? Did it flip? Yeah, it flipped. So instead of up, it's now down, right? This is down here, this is up here, this is up, this is down. Okay, it did flip. Vertical stretch, it looks skinnier, right? Very good. And then let's talk about the middle point, right? The middle point right there. We went to the right 3. Let's see, hold on. That would be our second down. So right here. 1, 2, 3. And look, it went up 4 because it would have been there. That one's a little bit trickier to do, right? Did I get all my stuff correct? This would have been to the right 3. 4. Sorry, guys. 0, 2. I add 3 here. Multiply by 2. Yep. Awesome. Perfect. Okay. More left. Let's just sketch these because this is exponential. Do you guys see? I see right here that it's exponential. So I know this is the parent function. So let's talk about what's happening. This is on the inside. Okay, inside, outside. So remember, inside we do the opposite to what we see. I see an adding 3, so that would be to the left 3 and up 2. Okay, the other thing I want you to keep in mind here is there is a horizontal asymptote right at 0. So if we were to move this horizontal asymptote, which way can you move the horizontal asymptote? Well, we can either move it up or down. You guys see that? So as you can see, which one moves it up or down? It's up 2. So the horizontal asymptote is now, instead of it being y equals 0, we're going to move it up 2. So it's going to be at 2. Because up, down for the horizontal asymptote. So that means right away, I can put my dotted line. Now, if you look at this table, right, we used our coordinate 0, 1. We're going to go left 3. So do the opposite to the x. So we're going to subtract 3. So we get -3 here. And on our outside here, we're going to add 2. So that would be 2. So -3, 1, 2, 3. Add 2, that would be 3, not 2. There we go. There we go. 3, -3, 3 is our coordinate. So -3, -3. Okay. And now we can sketch our exponential. Okay. So again, remember that the outside here is moving our horizontal asymptote. Okay. Same thing down here with our rational. Remember, our rational has a vertical asymptote and a horizontal, just like this. Okay, that's our parent function. When it's on the bottom, it's on the inside. Here's on the outside. Okay, remember the outside is going to deal with the horizontal asymptote and the inside is going to deal with the vertical asymptote. Okay, because here we're going to go down 3 and think opposite. So right 1. Okay. So I'm going to move this as my horizontal, because horizontal has to deal with up and down, and vertical left or right. So horizontal is going to be down 3. So 1, 2, 3. Okay. And then your vertical to the right 1. So for rational, we're going to graph our asymptotes. And then with our asymptotes, we always stay very close by. This doesn't have to be perfect. That's why it says sketch. And there we go. Because there is our parent. There is our new transformations. All right, let's see what we can do for practice. Take your time because there's so many different types of questions.